So for this last part of the lesson, and this is actually going to be the type of questions you're going to have on Delta Math more, we're going to talk about evaluating logarithms. So to summarize what we learned when we did the graphs, an exponential equation is set up in the form base to the exponent equals a number. Okay, so we call this number here the base, that's called an exponent, and then we're going to call it number for the other side. So what this looks like is we can actually say this is Venn form, and this is just a way to help you remember like a little memory device. When we write an equivalent logarithmic equation, so when we remix things, we write the word log, the base goes down low, the number that it used to be equal to comes over here, and then the exponent is the answer. So we can nickname this log Benny, okay, or Benny. So that's just a way to remember how to reorganize it. So therefore, if you have b to the y equals x, it can also be written as log base b of x equals y. So basically that exponent and the answer switch, and then you kind of write stuff on different levels and put the word log in the front. So when we see a problem in the form, and I'm actually going to zoom in on this a little bit more. I know you guys have the notes, but let's see, that's a little better. When you see a problem in the form log base of number, this can be read as the exponent. So the word log we can think of as the word exponent with a base of b that results in this number. Because when we look at a logarithmic equation, if we're trying to find the answer to this, we're looking for the exponent for this number, for this base, that gives us this number. So once we see one, that'll make a little more sense. But basically, when we see all these problems in exercise 2, we're really looking for what exponent works, for example, on A, for the 2 to give me 8. So I'm just going to write that here. We're not going to write every single one. When I see log base 2 of 8, I'm asking what exponent for 2, that's the base, gives me 8. What exponent for 2 gives me 8? Well, 2 to the third is 8, so that exponent is 3. Okay, so that's what the answer would be. You're looking for that exponent. Now, we do have a way to kind of rewrite this. Once we get to some harder ones, we'll talk about writing it in exponential form. But for this first section, I just really want to make sure you understand what they mean. So log base 4 of 16. What exponent for 4 gives me 16? Well, that exponent is 2. Okay. Next one, what exponent for 5 gives me 625? So this one's a little trickier, but 5 to the 4th is 625. So that answer is 4. Next one, what exponent for 10 gives me 100,000? If you haven't noticed, those powers of 10 are actually pretty easy because if you count the zeros, that's what the exponent is. So I have 5 zeros, so that's 10 to the 5th. So the answer is just the exponent. Even though I'm saying like 5 to the 4th is 625, the answer to the logarithmic problem is just the exponent. Now, heading into ones that are a little bit trickier, I want to show you how you could rewrite these to figure them out. So let's say I was having trouble with this one. What I could do is I could actually put an X in that spot, okay? I'm going to label everything. This is my base, right? And this is my exponent, and this is my number. Log Benny, right? That's our log form up here, okay? I could rewrite it in the Venn form, in the exponential form. When we write the exponential form, the word log goes away. So here, base is 5 to the exponent equals the number. So I'm just putting it back in that exponential form. From here, I could do that method of common bases. So x equals 4. So that means, right, we put the x here. That means the answer to this is 4. So I know that seems like a lot more steps, but you might need to do that as the problems get harder. Number one most important thing is that you remember when you see log base 5 of 625, you're looking for the exponent for 5 that gives you 625. So let's look at some other ones. I'm actually going to write these in their exponential form, but you might be able to figure these out in your head. So base to the exponent equals 1 over 36, right? Base, exponent, answer, or number. So because that's a fraction, we need that negative exponent, so that's -2. So I'm actually going to erase the x and just write -2 here. Okay, so that's also, maybe you want to write it and then just write the answer up here. Base to the exponent equals the number. So this one, maybe you need to take it a step further and write 2 to the x equals 2 to the -4. So x equals -4. But remember, that's telling you ultimately that this answer up here is -4. So here's a couple more that get a little trickier. I'm going to erase this part here just so I have a little more room. Hopefully you guys have enough room to do that one. So I'm going to say this one first. What exponent for 5 gives me the square root of 5? Well, the exponent for 5, that's the same thing as saying the square root of 5, is the 1/2 power. Okay? If I wanted to write this out further, right, I could put it in exponential form. And then maybe that would help me think about the fact that the square root of 5 is 5 to the 1/2, and that's why 1/2 is my answer. But no matter what, okay, 1/2 is the answer to that one. Letter H, a little bit trickier. So thinking about this, what exponent for 3 gives me the 5th root of 9? So to get that 9, I need to square the 3. But then the 5th root would go in the bottom of the exponent, right? Roots are the denominators of the exponents when we write the exponents as fractions. If I wanted to do this one further out, 3 to the x equals the 5th root of 9. I could write this as 9 to the 1/5, and then 9 is 3 squared. Okay, and then if I multiply this out, right, this would be 2 over 1, so 2/5. Okay, no matter what, this one, the answer is 2/5. And this one is actually trickier than I think you're going to see on Delta Math, but I just wanted to kind of get that thinking going. So now we just have a multiple choice and some equations to solve. This one says, between which 2 consecutive integers must log base 3 of 40 lie? So to think about this one, we're saying what exponent for 3 gives me 40? Now, there's no integer exponent for 3 that gives me 40 because 40 is not a power of 3. But I do know that log base 3 of 27, the exponent for 3 that gives me 27 is 3. And I also know the exponent for 3 that gives me 81 is 4. Okay? So this answer has to lie between these two answers. So the exponent has to be between 3 and 4. So that would be this answer here. So that's more of a thinking question. The last section I actually think is a little easier than thinking about evaluating logarithms. We just have to take these and put them in exponential form and solve them. So I'm going to write this out. Log base number equals exponent. And then we're going to put it in our exponential form. So my base is 4. My exponent is 5. And my number is x. 4 to the 5th, I could type it in, but hopefully I know that. So 1024 equals x. I'm just going to use this form for b as well. So now my base is x, my exponent is 3, and my number is 216. So I'm just rearranging it back into this Venn form. Different ways I could solve this one. I might just know the answer is 6. If I really want to get rid of this 3, I could use a 1/3 power. And 216 to the 1/3, the cube root of 216 is 6. But as I said, you might be able to just figure that out in your head. So my last one, my base is 5. My exponent is x. Okay, and my answer is 625, my number. So from here, maybe I just know it's 4, or I want to do common bases for this one. And and I get